What if I told you your network is paying for 8 ports but only using 1? Without EtherChannel, Spanning Tree is silently blocking your backup links. In this video, I'll show you how to combine multiple ports into a supercharged 8 gigabits per second pipeline that STP can't touch. Plus, the secret protocol that does it automatically. Ready to unlock your network's hidden power?
In this lesson, we will discuss EtherChannel, which is also known as Link Aggregation. EtherChannel is a technology that combines multiple physical links into a single logical link. You will see how it works, as well as its advantages. On this topology, we have 2 PCs from one end to the other, on which 2 switches are connected. PCs are connected with interfaces 1 gigabit, and the link between switches is 100 megas. In this state, if one of the PCs sends traffic exceeding 100 megabytes, then we would have network congestion and the traffic would be interrupted. To overcome this problem, there are 2 solutions. Either replace the link between the switches with a much faster link, such as 1 giga or even 10 gigabits, or add several links and group them in an ether channel. If they are not grouped together in a channel Ethernet, the spanning tree protocol would automatically block 3 out of the 4 links in order to avoid network loops. Thanks to the Ethernet protocol, the 4 physical links will be grouped together in one logical link, while combining the bandwidth. The 4 links of 100 megabits therefore gives us 400 megabits. Not only will EtherChannel do load balancing on the different links, but in addition, it will manage redundancy. That is to say that if one of the links falls, the traffic will pass on the 3 other links in all transparency. In EtherChannel, it is possible to group together up to 8 physical interfaces. To configure the EtherChannel, we have the choice between 2 protocols. PAgP, which is Cisco-owned, and LACP, an IEEE standard. These 2 protocols can dynamically configure an ether channel. It is also possible to configure either static negotiation, without one of the 2 dynamic protocols doing so. If we want to create an ether channel, we must ensure that all the ports have the same configuration. That is to say, same duplex mode, same speed, same native VLAN and VLAN authorized to circulate, as well as the same switch port mode, i.e. trunk or access. The 2 protocols check, anyway, if the configuration of the ports at the ends is indeed identical. The PAgP uses 3 statuses in its configuration. Auto status is the default mode. The port waits for negotiation to become an aggregation. In desirable status, the port negotiates with the neighboring port. And the status on is used to declare an active aggregation without any negotiation. In this case, there is no need to use PAgP or LACP. LACP also uses 3 statuses identical to PAgP, except that the name is different. Passive is the default mode. The port waits for LACP packets from opposite to respond, but does not send any by itself. Inactive, the port negotiates with its neighbor, and in the on status, there is no negotiation. And here is a table representing the modes of compatibility with the PAgP and LACP statuses. To configure an aggregation, you must choose the physical ports that you want to connect to the neighbor, enable PAgP or LACP protocol on these physical ports, and define a logical interface. If we change the configuration on a physical port, it changes the behavior only on that physical port. And if we change the configuration on the logical port, this changes the behavior of all the physical ports belonging to this logical port. For the CCNA, it is necessary to know the different modes of PAgP and LACP so as not to mix them up. You will inevitably have a question about it.